All right, everybody. Hello. Today we are going to look at a freshly released new sample that Unity released on Tuesday, it seems like. It's called ECS Galaxy sample. And it's basically a small simulation type of thing, like which sort of works like gameplay, but it isn't really a game because you can't really interact with it. It just does automatically do the thing it does. So let's have a real quick look at this blog post, and then we're going to jump straight into uh, the game itself, look what it does, how it works, and then we are going to explore the code together. Now, there's a caveat here. I haven't really looked at it a lot. We're going to be doing this live, unedited, just trying to see if there's something interesting that we can maybe learn from this project together. So let's have a look. Now, this is a screenshot of the game. We're going to have a look at the game in a moment. I built it already, and it's already running in the background, so that's going to be interesting. Hello, everybody. We've just released ECS Galaxy Sample, a project showing a large-scale simulation of several teams of spaceships fighting for the control of planets. This is a fully automated simulation, but players can spectate using different camera modes. Players can also bring up a settings menu during play to tweak some simulation parameters in real time. This sample aims to strike a balance between being simple and lightweight enough to be easy to learn from and involving enough non-trivial ECS game code, AI, spatial queries, event-based logic, different unit building types, and roles, etc., to make an interesting showcase. You can find the project here on GitHub, so it's on GitHub. If you want to check it out yourself, just clone this and run it using Unity 6. So it's going to require you to use the Unity 6 preview. Then there's a couple of README files, a game overview, code overview, and debug views. I haven't really looked into debug views yet. Maybe we can do that together. If you experience any issues or would like to share feedback, give feedback, basically. So this is basically it. So as you can see, I've already let it run a bit. We are currently averaging 110 FPS and have about 65k, and that is with recording 65,000 chips, sorry, and that's with recording the whole shebang here in 4K on OBS. So when I run this without OBS, I get like, I don't know, 150 to 200 FPS running on a AMD Ryzen 5800X3D with 32 gigabyte of DDR4 RAM on a 4090. But rendering isn't really like the big issue here. It's very simple visuals. As you can see, it's like these little spaceships, which also have like LODs, and they are like very simple. And then there's also like some visual effects. And as you can see, the whole thing is paused right now, and that is because you can go to this settings menu and play around with some of these settings. So I'm going to return to a time scale of 1 here, which hopefully should it doesn't seem to be working anymore. Okay. Let's restart it then and see it from the beginning. So if we click simulate here, it now starts. We can fly through this world and maybe pick a team to visit. So we have 4 teams: blue, green, yellow, and red. And then, as you can see, basically how this works is you have these planets. This is now owned by the blue team, and then they spawn like these structures, and then these structures, as you can see, they poop out all these random spaceships. So there's like small ones, then bigger ones, and then even bigger ones, and they are flying towards these neutral planets here, trying to capture them. And then they when they've captured them, they basically start again with building structures and building units, and then when units of different teams encounter each other, they start fighting each other. So this, we've actually seen the first contact here between blue and yellow. And that's basically how it works. And as you can see, we have an ever incrementing amount of spaceships uh, being spawned here. And right now we are at 400 FPS. And yeah, that's basically it. And this is going to run forever. Now, as I've already shown you guys, we can go to the settings and maybe increment the time scale to speed up the simulation, which works. But for some reason, when I set it to 0, it somehow broke it. So there's other stuff. We have like a fixed simulation rate that we could. So that's basically setting it to 30 FPS or what's going on here. I'm not sure what this actually does. Even though this seems to be a little bit fast for 30 FPS, to be honest. Yeah, I'm not really sure what this means. Let's maybe set this to 60, which is for some reason slower than 30. What if you do 10? It gets even faster. Yeah, I'm not really sure I understand how this works. And then we can set stuff like max ships. Let's see, what else do we have here? Planet spawn. This is all the stuff you can set up for. I would assume you can maybe change this before you start the simulations. Let's try going back to the main menu. Then okay, we can actually. Oh, let's try increasing the team count to 8, and then maybe I don't know. What can we do? Planet spawn radius, maybe increase this a little bit. Neutral planet count, let's increase this also. And see what happens. So okay, as you can see now, there's a lot more going on. We have we also have different camera modes, I think. Let me which button was it? There, Y. Okay, with Y we can actually sort of focus on a random planet. We can follow a random spaceship, but yeah, so as you can see, we now have this pink team. So the colors seem to be like somewhat predefined, or maybe they are sort of procedurally generated. Let's see what happens if we actually. I like to play around with stuff. If we actually like do 20 teams, and then hit simulate, what happens now? Do we actually get like? We seem to be getting a duplication in color. So we have this teal team, and then we have this, which for me kind of look the same with the pink ones and the yellow ones. So it seems to have like a limited range of predefined colors that is not like procedurally generating them. Let's maybe speed this up and see how chaos ensues here. So this is I find this kind of fun just from the actual act of looking at. I find this kind of mesmerizing, and I really love it. It's super fun, and I could totally imagine a game built based on this, like with some extra gameplay. I'm actually currently considering maybe taking the sample and adding some gameplay to it, or yeah, not sure. So we are currently, let's see, at 65,000 spaceships, and adding teams probably also adds to the complexity of all the stuff, because I would assume that the game itself has to check between all the teams, and therefore this now 65,000 spaceships runs a bit slower, but this is probably still more than you're ever going to need in a real game. I would assume like this if you actually wanted to make this a game, this seems to be kind of unmanageable from like a human perspective, like to actually being able to make decisions based on this kind of amount of stuff happening on screen. So you probably would be good if you had less. Let's try to maybe reduce the number here. Let's see what happens if we actually do it while the game is running. Does it destroy? So it doesn't. Okay, it doesn't seem to be respawning ships anymore. So yeah, that seems to be happening, and we actually seem to be running into a situation where now there's only one faction left. Oh, we actually have a winner, it seems like. That's cool. So yeah, that's the project. I highly encourage you to download it and check it out. Now let's dive into some source code here. So let me real quick exit here and open up Rider. So this is the project in Unity. It's seems to be a very straightforward setup. It's just some VFX probably for the combat stuff, some some space background. So this is very basic. So yeah, everything is being spawned basically at runtime. So there's not much baking going on. So let's have a look at our README file. So here you can see the controls. There isn't really much you can do. You can fly around, right, and then control the camera basically. Then we have our game overview. So let's maybe zoom. How do I actually go to presentation mode? Hello. Yeah, you can totally see I'm not prepared for this at all. So let's have a look. This game is an automated simulation of several teams of spaceships. You can see these are the different kind of spaceships. You have fighters, workers, and there's actually traders. Traders try to uniformly distribute resources across all the planets captured by a team. That's cool. Then we have factories, we have turrets, we have scene turrets. We actually, there are actually spaceships. I think the big ones here that actually, yeah, you can kind of see them here. They have actually turrets attached to them, which is kind of neat. But the trader stuff, I mean, that's something you don't really notice during this gameplay, right? So yeah, that's interesting that they have this this kind of stuff in there. So is there anything else interesting here? No. So this is just a description of all the basic things. So yeah. We've already seen all of that. Read me. Let's go back there. Why does this not? Okay. This is sort of bugged. Yeah. Let's go back to the normal mode then again. So here we go. Now we are at the code overview section. How do I? I'm not really okay. You can only zoom in the code view, it seems, and not in the preview of the MD file. Well, interesting. Let's give us a little bit more space then here. So our game initialization is handled in game initialize system. So let's have just a look at one of these systems. I'm just curious about how the Unity team actually goes about organizing their code. So it seems like all of this, is this just one big system? Is that all there is in this file? Can you not do this? Yeah, there's just one. Okay. That's interesting. Yeah, I'm not sure if I'm a big fan of that kind of organization, but you know, it is what it is. So let's see what this actually does, just to get okay, the game initialize system is just it just does all the spawning, so there isn't going to be any queries, so that's not going to be super interesting. Then we have like the authoring stuff. I've already looked at this. So you basically have these authoring components, which are just basic, authoring with bakers, and they also have like these require components, which means that if you want to author a file, you will also have to add a ship authoring, which I guess it's fine. You can totally do it this way if you like to. By the way, this is called require component and not require mono behavior. It is sort of It just dawned on me when I looked at this code, but it's kind of triggering me now because component is now pretty in ECS land. Component is sort of a reserved term, so it's kind of confusing. Yeah, but you know, this existed way before ECS, so I guess that's why that is. So we have like different authoring components. Then I would also assume that there are maybe some prefabs. So let's have a look at maybe I don't know, the trader ship, just out of curiosity. Okay, and there is like a bunch of authoring components, right? We have the ship authoring, we have the trader authoring, we have some material stuff, which is oh, you can actually, this is nice, an entity name authoring can, so basically you can control how it's going to be named inside the entity hierarchy, which usually I just take the name of the game object prefab. So yeah, not really sure because it's also the same. Yeah, whatever. You can. I'm not going to be judging it. So let's have a look at this ship authoring, for example. Because there's something I found interesting. There is this ship data object, which I assume is one of those scriptable object thingies. Why doesn't Rider? Okay, that they might be using or not. Let's see. We have the ship data struct. Is there more in here? Okay, and then we have this baked scriptable object, which basically wraps the ship data. I kind of like this this approach. So you have like a scriptable object. Let's have a look. That contains all your data. Now this is sort of I kind of don't like this. That you have to actually open this, but that's just Unity. You could fix this with using like Odin Inspector or maybe like some custom inspector code, but it's not really super important. So basically, we now have a separation of the prefab and the data that is assigned to that prefab, which controls like all the behavior. There arguments could be made that it's not necessary because it seems to be like each ship has one data object assigned to it. So there's like you don't really seem to be reusing a lot of stuff, but I might be wrong about that. So I've been struggling with that kind of stuff in my own game as well. Like, do I use scriptable objects for my data, or do I just use like prefabs as my authoring system? Scriptable objects usually only make sense to me if you use one scriptable object in multiple instances, which yeah, depending on your game design, you might need, you might not need. So yeah, that's why I'm curious. I'm wondering, is there maybe like a ship data for each trader? No, it doesn't seem to be. Like, you have this trader. Let's see at trader B, trader. It's like you have one prefab and then you have like one data object for each. So this could also be just inside the authoring component, right? It wouldn't really make that big of a difference. Yeah, but I digress. So let's have yeah, go back to our README files here. So blob data authoring, that's basically what we just were looking at. So how this works is we have scriptable objects that use this baked scriptable object base class, and that basically it's the data to a what should we call it, blob asset. Now that's probably why they are using scriptable objects, so they can just wrap all this data inside a struct. Now you could also just put a struct on the authoring component and then bake that down into a scriptable object. So there isn't not necessarily a requirement for scriptable objects, but of course, with scriptable objects, you could do other cool stuff like maybe exporting those into like an Excel file, or and then you can tweak your data in Excel with like formulas and stuff. Like there are pros and cons to this. So what this actually does is just generalizes the code for building blob assets, which I am really for. I really liked it because building blob assets is like, and if anybody of Unity ever watches this video, it's like the most painful thing ever. And this seems to be fine, but if you have like some sort of nested data structures or something like that, which probably you shouldn't do, but I have the tendency to use those for some reason, it can get really, really, really annoying to work with as blob assets. So yeah, that's basically from like a high level overview how this works. So yeah, this is how the ships are basically authored. Then we have planets, handles building, planet system. Let's have a look at the planet system because that's actually a gameplay system that should be querying some entities, I would assume. So it actually uses jobs, which totally makes sense. So let's see. We have the planet system itself, and that's basically it. Okay, so the approach seems to be to have like just one big system and then have all the different queries and stuff and jobs just executed one after another, one after another. I personally do it a little bit different. I usually have the tendency to have like one system per thing that I want to do. So I would probably move all of these into separate systems because it just feels a little bit more manageable for me, especially when yeah, when I look at the systems window. So I like to see like each thing that is happening in like a separate thing. But I'm currently honestly, I'm currently rethinking my approach of organizing code in a way. So I'm curious about what you guys might think. So I've been watching a lot of Hot Pass show and talks between Danny and Turbo about that kind of stuff, and it seems like they also approach it in a way that they just do like bigger files where components and bakers and all that stuff live together. And then there's this approach of having like one system that does like a bunch of stuff. So let's have a look at this real quick if we can get like a rough overview of what's actually going on here. So capturing workers. Okay, no, that's already a job. That's not what I was actually looking for. I'm not really going to go too deep. So we can see we have this planet ship assessment job, then planet conversion job, planet resource job, right? These are all things that happened differently. Now, the big advantage of this, when I look at this, is that you just very explicitly like determine the order at which this stuff is happening, right? So we first check our planet ship assessment, then we handle the conversion, and then we do the resource stuff, right? With systems, you sometimes run into the situation where you want to have stuff happening in a certain direction, so you need to do like the update before, update after, update in group, and it can get sort of cumbersome. And then there is this situation which actually makes me kind of like this approach. Let me, by the way, I seem to be clipping a bit. Let me turn down my volume just a tad. So this seems to be better. I'm sorry about that if my audio quality was a bit shitty until now. With systems, if you want to if you have like a couple of systems that sort of work together, that they're sort of related. Like for example, let's say you have like a combat system, right? Or like combat system in a sense of like a gameplay system, not like ECS system. So all everything related to combat, right? And then you for some reason need to disable everything related to combat because I don't know, you have like you go into pause. Like a simple situation. You have like a pause button. You need your combat to stop, right? So you need to disable everything related to combat. How would you do that with like separate systems? It's a bit tricky because you probably would require to use system groups or something like that. And in this case, you could just use the enabled flag in the state. I'm not really sure if that works with system groups as well. So yeah, that's an interesting thing to think about, like how to organize your code. I'm curious at let's have a actual look at the folder structure here. So we have our scripts folder. Okay, so they seem to be following the approach of just have a separation between authoring and components, and then all their components are sort of grouped, but they still separate between authoring and components. So I've seen different approaches. Like I usually tend to group my stuff by feature in a way. So let's go back to that combat example. So I would have like a combat folder, and then inside that combat folder I would have like an authoring folder, a components folder, and system folder. Then each system, each component, everything has its own file, which can get a little bit annoying, to be honest. So what a lot of people would do is let's take this building, for example. There is this approach where you just put everything in a single file. So you have like your components, your authoring stuff, and your systems live in the same file, which I'm not sure. I can see putting authoring and components in the same file. I can totally see that, but also adding systems will result into like giga files. I would assume. It's like, I'm wondering what's like a big old system that they have. So they're doing some kind of separation. So I have like a laser system, ship system. Ship system is probably, yeah, that's a big one. Look at this big old boy. This for me that's a bit much, to be honest. I feel like this makes it really weird to navigate this stuff. So I don't know, especially when you want to switch between stuff a lot. It can be quite nice to just have like 3 files opens in parallel, and then you can just swap between them. And yeah, that doesn't work great here. So let's just have a look at this while we are here. So as you can see, we have a lot of jobs that are all called one after another, and yeah, then we also have the jobs inside here. That's also something I would in my current project I'm doing differently. I also have like a file per job, which is something that I'm currently also reconsidering. So yeah, I'm not sure. Maybe the approach is to maybe have like these big files, but then maybe break up your stuff a bit more. So instead of having like this whole everything related to a ship lives in the ship system, maybe you can break down a little bit the logic a little bit more. Like, I don't know. I'm not really sure what's happening here. We have like the initialization for the different ship types. It seems like we have AI stuff in here. We have the attacking stuff. So I could totally, like, for me, it would totally make sense to separate the combat and the AI part a bit, and then have like a combat file, an AI file, and then the ship file, right? But that's a very personal thing. I feel like the pain points are different for each individual. Like some people are totally fine and will probably use Emacs or something and hack through these big files. I am more of a keeping stuff in digestible sizes, and I'm not like functions can only have like 20 rows or stuff like that. It's more like a gut feeling that at some point stuff just feels too big, which is like super subjective, and probably only works because I'm working alone most of the time. But yeah, that's That's just how I feel about this stuff. So let's have a look at the overview. So most chip logic is handled in chip systems. So yeah, you can see what's actually happening here. Then there is a separate doc blog about the AI, even though the AI seems to be living in the ship system as well. So let's have a look at what actually is going on in here. AI in this game is implemented using a simple utility AI system, which is cool. Most AI calculations happen in team AI system. Okay, so there seems to be this is more of a overarching AI versus like an AI on the ship level. So the team AI probably decides, okay, this is like the planet we're going to attack, and these are the resources we need and stuff like that. And then the ship AI controls, okay, this is how I have to point my ship to actually fly there, and this is how I decide when I attack a ship or collect a resource that I'm nearby. So more low level versus like general level planning, which makes a lot of sense. So utility AI, basically how it works is you have like different actions that a AI can take, and then you basically value each of these actions based on some criteria, and then you choose the action with has like the biggest value assigned to it. That's basically how utility AI works. It's a very nice way to write AI for very complex systems. I'm not sure if I would have chosen it for this kind of simulation. Maybe it makes sense. I'm not sure. It depends on. For me, it depends on the amount of decisions that actually need to be taken. Right. For like if you have like an AI that doesn't really do much, then probably a state machine is a little bit more explicit, right? Because you can reason much better about how you go from one state into another. Whereas with utility AI, you can basically jump from any state into each different state, and yeah, it can be tricky. But what I'm curious about is how they implemented that stuff in ECS, because I was always thinking about how I would do it, and I'm totally going to dig into this example. And then we have stuff like entity initialization and death. Okay, so there's probably not going to be much interesting here. Health component, yeah, sure, you need to have health in order to know when you are dead. Basic stuff. This one here is interesting to me. Acceleration structure. So what this means, as far as I could tell, is it's about data structures. So let's have a look, because this is going to be a very interesting part. The spatial database, which sounds like a fancy gameplay feature, but it's actually more of a data structure. The spatial database allows fast querying of entities in a bounding box. So it's basically spatial partitioning, right? You have like you can do this in 2D or 3D, but basically you have like a big space, and then you separate it in smaller spaces, and then each entity is in a region of a space, and if it needs to find like something that is nearby, it only has to query like the small partition around it, and maybe the one that surround that partition, and then it can ignore the vast majority of the rest, which is very important in a game like this, I would assume. So the world is divided into a uniform grid of cells around the origin, and cells store information about which entities are within their bounds. Every frame, a clear spatial database system clears all stored data in the spatial database, then builds spatial database system, iterates over all chips and buildings, and adds them to the spatial database calculation which cell they belong to, and add themselves to the cell. So it's basically you how this works is you take your position, right, and then based on the configuration of the cell, you can just calculate from your position in which cell you are, right? And then you just add like an index or something to that entity, or you can maybe add that entity to a list, like depending on the use cases you might have. And then you can basically use query AABB, so you can use an access aligned bounding box. I mean this is cool. This is totally useful for other kind of games, and It's nice that there is a sample for that you could just yoink from that code, which is like one of the cool things about ECS project is that it's usually very simple to just take a small subsystem of a project and just move it completely to a different project without any issues, which is cool. Then we have the planet navigation grid. Allow fast planet avoidance for ships. So this sounds interesting. The world is divided in a uniform grid of cells around the origin. Each cell computes and stores data about the planet that closest to that cell. During the game, ships use the planet navigation grid to verify efficiently process very efficiently process planet avoidance. Okay, if I can read, that helps. With simple math, they can calculate the cell index where they currently are and access the closest planet data at the cell index. Knowing the distance, position, and radius of the closest planet, they are able to compute planet avoidance only on the planet that matters, only when they have to, and without requiring lookups. The navigation grid is computed once on start in create planet navigation grid and is used in ship navigation job when calling this code. That's interesting. Planet's network allows fast neighbor planet searches for AI. So that's basically like a little node graph, right, where each planet is connected to the neighbors it has, and then you can basically um, very simple just pick and like this game only pretty much needs to choose like where to go next, right? So you don't even have to traverse from between like 2 points over a node in between. So you just go from one planet to the next and you don't go to the next after that until you've reached that. So you don't even need something like a star or something to determine where to go, which is cool. And then last but not least, all VFX in the game is handled by VFX system and VFX graphs. At the scale required by this game, spawning one VFX graph game object per VFX instance would very quickly become a performance bottleneck. Instead of this, we use a mostly game object-less approach, where every instance of a given type of VFX is handled by one single pre-instantiated VXF graph in the scene. That's interesting. I didn't know that's actually possible. Each VFX instance is a spawn a VFX here message sent to a single VFX graph object through graphics buffers. Ooh, that sounds fancy. I have no idea how this works. This approach allows spawning a very large amount of VFX very often at very little cost. VFX system holds one VFX manager for each type of VFX in the game. Lesser Sparks, Explosion, Thrusters, VFX managers hold native collections of VFX requests during the game. Various jobs will write to these VFX request collections in order to ask for VFX to be spawned. For example, fighter execute attack job creates request for laser sparks effects, creates request for explosion effects, creates request for to spawn a thruster. So that's super cool and interesting to me because that's something I didn't know you could actually do like this. Maybe we can have a look at one of those VFX graphs. Explosion graph. Let's see, maybe we can quickly find out how this works. VFX explosion request, spawn event, spawn batch. So there's this event, and now we would have to find out how this is actually. Let's see if we can find this in the code real quick. VFX system, VFX scarf, send event, spawn batch ID, request count ID. Cool. VFX graph. What kind of system is this? Is this a system base? VFX manager parented where? Okay, that's interesting, but also a little bit too complex to dive into on the fly. I'm totally going to have to check this out. This is super interesting. I was wondering how they do it because there is a lot of stuff, like a lot of explosions and stuff happening after some time, right? So yeah, that's really cool to me Yeah, so and this is why I like these sample projects, right? They are a good way to pick out at least some useful information. I'm not a fan of learning only through sample projects because each sample project has like very specific use cases and criteria that they work around. Right, this game has some very specific gameplay situations that require very specific solutions. And some of them are more general than others, like for example utility AI and the VFX graph I think could be applied to a lot of games. The spatial partitioning stuff maybe for some games, and then like the planet graph stuff is probably not going to be useful for a lot of other games. So learning from samples also requires you to actually understand why stuff has been done that way. And we actually have a winner. Red is totally owning here. And we now have 100k ships running in the editor, and now everything is sort of confused about what's actually happening. Oh man, this sort of kills FPS when I go because now it loads in the very detailed LOD, and we have like a bunch of spaceship with the detailed LOD. Interesting project. Yeah, I'm curious about what you guys think about that. I'm totally going to try to maybe add some gameplay to this, like real gameplay, interactive gameplay, and yeah, that's going to be it. I think for now. We've already been going on for quite a while now. So yeah, let me think about what you like about this sample project and about this style of video. If you would like to see more of that kind of stuff, make sure to subscribe and like the video. And I see you around very soon. Have a good one.